In this video, we're going to look at Azure Stream Analytics, which performs real-time analytics by collecting data from one or more streaming inputs and then combining that data using complex event processing to look for important patterns in the data. The resulting patterns or events are then output to a new stream to be consumed by downstream processes, such as Power BI or a data store. The events can trigger other workflows as well. For instance, I've personally designed an alerting system for IoT devices that uses system analytics to determine anomalies in the data and then notifies users. There are many scenarios where stream analytics is useful. It can be used as part of a workflow for geospatial analytics, such as managing fleets of trucks on the road. For expensive assets such as wind turbines, it can be used to monitor the systems and even predict failures. For online sales, it can perform real-time analytics to determine patterns. It can generally be used to analyze click streams or how users click through your website. And one I'm most familiar with is real-time telemetry for IoT devices. In fact, besides running in the cloud, stream analytics can also run on the edge, or in other words, right on an IoT device for faster response. Azure Stream Analytics has the following key capabilities. It's flexible enough to meet real-time needs, such as being able to run on the edge. It's reliable because it supports retries to ensure data is processed and has reliable temporal functionality to integrate multiple input streams with potential time delays. And it scales to manage large throughput. Stream Analytics works in 3 phases. In the ingestion phase, data is read from real-time streaming sources, such as stream data from IoT devices or real-time click data from a website. The streams are analyzed real-time in discrete batches to identify events in the data. The resulting stream of events is then delivered to downstream processes. Examples are Power BI, which may chart the real-time events, a notification system that may notify users, or a data store where the events are stored for further analysis. Azure Stream Analytics makes it easy to implement these 3 phases. It supports connectors to multiple sources. As mentioned, multiple real-time streaming sources can be supported. Likewise, there are many output connectors available, such as Cosmos DB, Power BI, or HD Insight for analysis. The batch analytics that occurs between the input and output is simplified through SQL-like logic with useful temporal functionality to manage streams. Azure Stream Analytics is a complete platform as a service offering, meaning it's self-contained and self-managed. You can spool up an instance in minutes and don't have to worry about the underlying infrastructure. Instead, you only have to focus on the logic of your stream analytics. Stream Analytics guarantees that all data streaming as input is processed exactly once, and that all events going to the outputs post-processing are delivered at least once, meaning output targets may need to deal with duplicate events, but they won't miss any. Azure has an SLA on its processing of 99.9% availability. This means the service is reliable. It meets many compliance certifications as well. And Azure Stream Analytics supports TLS 1.2 and encrypts all incoming and outgoing data channels. In-memory processing means data is not stored. System analytics can also be used with virtual networks for added security. Azure Stream Analytics offers a SQL query language that allows you to process stream data. You can also use a host of other programming tools to create the processing logic, such as PowerShell or Visual Studio. The query language includes support for complex event processing through temporal functions that allow you to synchronize batches for different streams. Stream Analytics is often used in a hybrid architecture. In the cloud, it can perform analytics where latency is not a big concern, such as picking events of interest out of the data for further analysis. This can be combined with Stream Analytics run by an IoT edge device, which can identify events with very low latency. This might be used, for example, to send out notifications for time-critical events in real time. With Stream Analytics, cost is optimized. There are no base costs. You pay for what you use. And jobs can be scaled for maximum cost efficiency. One of the most important features of Stream Analytics is its performance. It can process millions of events per second, so it can process a lot of data in a very short amount of time. This means the results are very low latency. Or in other words, Stream Analytics responds with output very quickly. Paired with IoT Edge, it can respond even faster. It's highly scalable to manage more streaming input, and it takes advantage of partitioning to process streams in parallel for faster processing. Data inputs are a connection to an existing source of data. A single job might connect to one or many inputs. In the following slides, we'll be looking at the 4 input sources that Azure Data Streams is designed to integrate with. Azure Event Hubs is a fully managed ingesting technology which can accept millions of events from other sources real-time, then store those events internally, partitioning for performance, until they're consumed by registered consumers. Azure Stream Analytics can be one of those consumers. An Event Hub is a good way to stream large throughput from other sources into Stream Analytics in a reliable manner. Azure IoT Hub maintains a secure communication channel to potentially 1 million IoT devices. This way, devices can stream data to this cloud-hosted solution, which can then serve as an input to Stream Analytics. IoT Hub is scalable as more IoT devices are registered. Azure Blob Storage can also be an input to Stream Analytics. It stores data, creating a data lake for analytics that Stream Analytics can then consume. Azure Blob Storage is also commonly used as storage for apps, both mobile and cloud-native apps, because it's simple and inexpensive. Blob storage is a low-cost option for storing data for analysis. So for instance, if you have several Stream Analytics instances that work on the same incoming data, you might land that data in Azure Blob Storage and then connect it to the Stream Analytics instances as a common input. This wouldn't add a lot of cost to the solution. Finally, Stream Analytics can accept an Azure Data Lake storage account as an input. Azure Data Lake is dedicated to big data analytics rather than Stream Analytics, but there's no reason you can't do both. For instance, you could use a data lake for batch data analytics and also streaming analytics to capture important events in the data as it streams into the storage. As a developer or operator managing these input connections, you have several options regarding technology. You can manage the inputs to Azure Stream Analytics using Visual Studio project templates targeted for Stream Analytics, the .NET API library, which is a library for calling the Stream Analytics REST API, or you can call the REST API directly, you can use Azure PowerShell, and you can even configure inputs via the Azure portal. So now let's look closer at what a data stream input is. A stream, by definition, is an unbounded sequence of events. This just means that data streams in sequentially, or in an ordered fashion, with no distinct start or end. The data stream can ebb and flow. That is, data might slow or even stop at times, and come in at a higher throughput at other times. This is still a stream, as long as the events streaming in are sequential and don't have rigid start and end boundaries like batch processing does. Stream Analytics requires at least one data stream input to work. This should make sense since it's designed to process streams, so it can't perform without input. It can support multiple input streams. As we've seen, these data streams can come from Event Hubs, IoT Hubs, Azure Data Lake Storage, or Blob Storage accounts. Additional to incoming stream data, Stream Analytics can also input reference data. Reference data is data that's either completely static or changes but very slowly. It's not sequential stream data, but rather is used as reference for the stream events coming in. You can think of reference data as a table that can be referenced by some identifier in the stream data. As a simple example, imagine stream data is coming in from an IoT thermostat. Each data reading or event that streams in from the thermostat has the raw reading, a timestamp, and an integer that refers to the unit of measure. Say 1 means Fahrenheit and 2 means Celsius. A simple reference data input might be a CSV file from Azure Blob Storage that contains a column with the numbers 1 and 2, and a second column which is the string representation of the unit, Fahrenheit or Celsius. The stream analytics could use that reference data to output the proper string name for the unit, rather than the raw numbers 1 and 2, which might not make sense when somebody's looking at a Power BI display. Reference data can be read from Blob Storage, Data Lake Storage Gen 2, and Azure SQL Database. It has a size limit per reference of roughly 300 megabytes. Input streams can also be compressed. This is often used to avoid data event size limits in stream analytics, as well as to avoid excessive bandwidth. The options are to have no compression at all, to use gzip compression, or to use deflate compression. Additionally, if Avro data is being streamed and it's already compressed, then there's no need to specify a compression. And it's important to note that reference data cannot be compressed. To review the 3 phases of an Azure Stream Analytics job: inputs stream data into the service. A query performs the processing that's at the heart of the Stream Analytics service. This queries the input stream and results in a new transformed output stream consisting of new data events. That output is then streamed to some output targets. In this video, we're going to look at the output phase of the Stream Analytics job. As a developer or operator, there are many ways you can manage Stream Analytics outputs. You can use the project templates in Visual Studio. You can use the .NET API library, which aids communication with the Stream Analytics REST API. You can communicate with the REST API directly. You can use Azure PowerShell. And finally, you can manage outputs using the Azure portal. In the following slides, we're going to dig into the different types of Stream Analytics outputs. Stream Analytics supports Azure Data Lake Storage Gen 1 as an output. Azure Data Lake supports big data analytic workloads, meaning it can store data of any size, type, or ingestion speed. This is ideal if you want your Stream Analytics to output events which feed big data analytics downstream. It's important to note that Stream Analytics must have the proper permissions to Azure Data Lake Storage in order to write to it. Azure SQL Database is also supported as a Stream Analytics output. It's ideal for data that's relational. So for example, if your Stream Analytics job analyzes a stream of temperatures from an IoT thermostat, it may be looking for events during which the temperature goes out of certain limits. The output stream may consist of those out-of-normal events. In the output, these events may be grouped by type to facilitate notifications to users. This is very relational and might be stored in a SQL database. When you stream to SQL database, you'll likely want to streamline it for write efficiency, so it can keep up to the real-time stream. With this in mind, Stream Analytics allows fully parallel writing to a SQL output, which can speed writing up tremendously. One thing to keep in mind is that write order is not guaranteed between different parallel write streams, but this might not be an issue if your output is highly parallel in nature. Your table schema and database configuration will affect the maximum throughput for your writes, as will indexing of your tables, clustering, index fill factor, and compression. Azure Synapse Analytics can be used as an output for Stream Analytics. It supports both enterprise data warehousing and big data analytics. Like data storage, it's a good choice if you want to perform big data analytics of your output stream. It relies on a pre-existing SQL pool table in Synapse Analytics, whose schema must match the schema of the events in your output stream. Only table storage accounts can be used in Synapse Analytics for this. Data Lake Storage Gen 2 can also be used, which, like Gen 1, supports enterprise data lakes in Azure. Also like Gen 1, it supports massive amounts of data. and it extends Gen 1 in that it uses a hierarchical namespace that's compatible with Azure Blob Storage and takes advantage of its cost structure. When writing to a blob storage like data lake storage, you can make the output write more efficiently by using partitioning. Partitioning means that Stream Analytics will split the output into partitions that can write in parallel, improving write performance. You can partition according to the unique string values of custom fields or attributes. This gives control over partitioning to the processing logic, which can generate a custom partitioning field. To make output events compatible with downstream consumption by Hive and HD Insight, Stream Analytics also supports custom datetime path patterns in the paths of the resulting output data. Event hubs can be used as output from Stream Analytics. An event hub is a highly scalable event ingestion service that can serve its output to multiple consumers downstream. Further, it can guarantee order of events per partition. So if your architecture downstream from Stream Analytics fans out to serve the output to many consumers, and especially if data order is important, event hubs might be a suitable solution as an output. Power BI as an output allows you to stream output for users to view graphically in dashboards. It lets you specify a group Power BI workspace for sharing the data with others. You can specify an output alias when connecting to Power BI, and this alias can be used in your SQL query. You need an identity to authorize the connection between Stream Analytics and Power BI. This should ideally be an identity that you can modify later should you want to unauthorize the connection. And you specify the dataset name and table name to output stream data to. This becomes a dataset and table for real-time visualization. Stream Analytics can output to Azure Table Storage as well. You configure an output alias for this connection just as you do for Power BI, and then you can access the alias in your SQL query. You specify the storage account and storage account key so Stream Analytics can connect to it. And you specify the table name, the output field to use for your partition key, and the output field to use for your row key. This maps the output to the table. And finally, you specify a batch size. This is how many records in batches to write at once. This can be adjusted for writing efficiency, but 100 is a commonly used value that works for most jobs. A service bus can also be used as an output for Stream Analytics. A service bus, like an event hub, is an ingestion point for data. Unlike Event Hub, which only serves the data to multiple consumers independently, a service bus serves data either as a queue, which guarantees order, but each event is only consumable by one downstream service, or topics, where multiple consumers are guaranteed to get the messages. Message order in topics is not always guaranteed. Finally, Azure Cosmos DB can be used as an output target for Stream Analytics. Cosmos DB is a globally scalable data storage solution for big data. It can be optimized for the Stream Analytics output requirements because it's configurable to guarantee throughput. Therefore, if your Stream Analytics output has a very high throughput, you can simply configure your Cosmos DB to automatically scale and partition under the hood to guarantee that throughput requirement is met. Higher throughput configuration will result in more cost in Cosmos DB. Azure Stream Analytics gives you a SQLite query language for transforming input streams into output events. User-defined functions, or UDFs, provide additional flexibility for stream processing by allowing custom code to be written to process at the individual stream value level. 4 user-defined function types are supported by Azure Stream Analytics. C# user-defined functions can be written and tested in Visual Studio. JavaScript user-defined functions take advantage of JavaScript's functionality to perform custom functioning on stream values. Azure Machine Learning can be integrated as a user-defined function, and JavaScript also has user-defined aggregates, which are functions specifically templated to deal with aggregating stream data based on time windows. There are a few limitations with user-defined functions that you should be aware of. User-defined functions only return scalar values. In other words, the result of a user-defined function is a single value, not an array of values or a table of values. You should avoid calling REST endpoints in your user-defined functions, because this will negatively affect performance. The system doesn't audit function invocations or return results. Some additional considerations are the statelessness of a user-defined function. Each call of a user-defined function is independent from the other calls. Additionally, your user-defined functions should be repeatable, in that if you call them with the same input, you always receive the same output. Avoid any code logic that would break this rule, such as relying on the current date or using random numbers. JavaScript offers many functions for processing in a user-defined function. String functions allow you to manipulate strings. Math functions are available for various math manipulations. Arrays can be used for more complex analysis logic. Regular expression functions allow you to search for complex patterns in strings. And you can manipulate date and time variables with the date object. Some use cases for JavaScript user-defined functions are parsing strings. The regular expression capabilities let you look for complex patterns. You can also encode and decode data with JavaScript. An example would be encoding to and decoding from base 64. The math functions allow you to do all sorts of computations, and there are many operations you can perform on arrays that expand the algorithmic possibilities. Adding a JavaScript user-defined function to Azure Stream Analytics is easy. You click the Functions option under the Job Topology section in the main menu, then choose JavaScript UDF under the Add menu. So how do you test your JavaScript user-defined functions? Unfortunately, Azure Stream Analytics doesn't support isolated testing of JavaScript UDFs. But since they're simply JavaScript, you can test their logic in a browser. Then, once you're finished troubleshooting the UDF, you can add it to your Stream Analytics job and call it via your query by appending UDF to the front of your JavaScript UDF's name. Next are JavaScript user-defined aggregates. These implement complex business logic, much like JavaScript user-defined functions. Unlike user-defined functions, which are stateless, user-defined aggregates are stateful. This means that each call to the function has a context of the previous call. These are called user-defined aggregates because this stateful behavior supports data aggregation over streaming windows of data. Here's a template for a JavaScript user-defined aggregate, or UDA. Note that it has several functions within it that perform specific tasks. The init function is called when the UDA first enters a time window, meaning a start and end time in which data is to be aggregated. For each value within that time window, the accumulate function is called, so the state of the aggregate can be updated. Note that the state variable is the stateful part of the UDA, because it can be used to accumulate previous values. In other words, the accumulate function is not stateless. It's aware of previous data via the state variable. And finally, when a time window is being left, the compute result function is called to return the aggregated result. As an example of this, the template as written will perform a simple sum aggregate, adding all the values in a time window, then returning that state sum in compute result. If the time window was 1 hour, then this would output hourly sums given an input stream. The .NET standard user-defined functions allow you to write stateless UDFs in any .NET language you like. This is a very flexible option because it allows you to import all sorts of .NET libraries for complex processing. For instance, you could use a library for machine learning. And speaking of machine learning, there's a special UDF type for that. You can use an Azure machine learning module as a user-defined function in your Stream Analytics job, which in turn allows you to employ any open source tools that are compatible with Azure machine learning. to perform the standard 3 machine learning steps, which are to prepare the data, train the machine learning model, and then deploy that model. Adding a machine learning UDF is as easy as adding any other type. First, you click Functions under the Job Topology section in the main menu, and then choose Azure Machine Learning Service under the Add options. When it comes to debugging your user-defined functions, both .NET UDFs and JavaScript UDFs can be tested locally using either dummy data or live data. .NET UDFs can be tested in Visual Studio, which contains many features such as the ability to share the UDF code among projects and integration with the Stream Analytics solution. You can also debug a UDF project in Visual Studio in the same manner that you do with any other project, by clicking F5. JavaScript UDFs have fewer options. They're not as easily shared among projects because they're entered right into the UI of the Stream Analytics job. They also require a test harness to be built or one to be found. For both these options, do keep scaling in mind. That is, when you test locally, you're testing the equivalent of one node of Stream Analytics running. Eventually, you're going to want to perform live testing on the Stream Analytics job itself to test how it scales with multiple nodes. In this video, I'm going to demonstrate how to create and consume a structured stream in Spark using a Databricks workspace. So I'm in Azure, I'm on my home page, and I have a Databricks instance set up, and that's really all you need for this demonstration. Mine's called Databricks 2255 under Recent Resources. I'll show you how you set up your own. I'm going to click Create a Resource at the top left. Now I'm on the Create a Resource screen, and in the search box, I'm going to type Azure Databricks. And in the drop-down, I'll choose Azure Databricks. On the Azure Databricks screen, I'll click Create. And now I'm on the Create an Azure Databricks Workspace page, and I'm on the Basics tab. Under Project Details, I need to choose a subscription. It's already chosen it for me. And I need to either choose an existing resource group or create a new one. I'll just choose my existing one. Under Instance Details, I need to give it a workspace name. So I'll give it a name that's just unique, like Databricks 2243. Choose a region. I'm going to leave the pricing tier as standard. And at the bottom left, click Review and Create. Now at the top in green, it says Validation Succeeded. So to create your own, you can now click Create at the bottom left. Now I'm going to click Home at the top left because I've already created this. And back on my home page under Recent Resources, I'm going to click my Databricks service. Now I'm on my Overview page. And on the right-hand side, I'm going to scroll the overview down and click Launch Workspace. So I'm logged into my workspace, and I already have this set up with a cluster and a notebook. So let me show you how it's set up. If I go to the left menu and I click on Clusters, fourth button from the bottom, you see in the table on the right that I have a demo cluster set up already. I'll show you how I set that up. If I click Create Cluster at the top left, and I'm on the New Cluster page, it asks me for cluster name, so it would be Demo Cluster, or any name you'd like to give it. And cluster mode, I set to single node. And then just click Create Cluster at the top. Now, if you've never done this before, clusters are going to take several minutes to start up. And so if I click on the cluster button to the left again, and now I have the table of clusters, my demo cluster shows a green solid circle to the left. That means that it's running. When it's spooling up, it'll show a little spinning icon there. But once it's a solid green circle, it means it's finished, and the state is running. So now I'm going to go to my notebook. So if I click on Home on the left, that's the second button from the top, and I look under my workspace under my name, Bill.Brooks, I have a notebook called Demo-Structured-Streaming. Now if you want to create your own and you're on this workspace, you can simply click the arrow to the right of your name, and in the pop-up menu choose Create, and then choose Notebook. And you'll get a Create Notebook window pop up, and you can give it a name. you can leave the default language to Python and choose your running cluster and then click Create at the bottom right. So I'm going to go to my existing notebook, and I've already got this all set up. And I'm going to step you through these steps for setting up a structured stream in memory and then querying it. So let's go through the command cells here. At the very top is command cell 1. Line 1, I say %fs. That's to set it to the file system. We're going to use some events that are set up for demonstration purposes by Databricks when you install your Databricks. They're internal examples. On line 2, I list Databricks datasets /structured streaming /events. So that'll show us what's in that folder. So let me hit Shift Enter on command 1. And in the results of command 1, you see that I see the paths of several JSON files. We're going to simulate a stream by reading those files one at a time. So going to command cell 2, line 1, it says %Scala. So that tells it to switch to Scala language. Line 2 says spark.sparkcontext.txt file, and it points to the path of one of those JSON files that we just listed. What I want to do here is show you the contents of that JSON file. So line 3 actually shows the contents. It takes the RDD, which is the text file that I've loaded, and it goes .collect for each, and it prints every line one at a time. So let me hit Shift Enter on this. And you can see the contents of the file. There are JSON objects, and each JSON object has a time and an action. The possible values for action are open and close. So we're going to set up a read stream in order to get that data read from the files to a stream, one file at a time. So in command cell 3, line 1, I'm bringing in the pyspark.sql.types library. Line 3, I'm creating something called raw input stream. Line 4, I'm using the Spark object. Line 5, .readStream. Line 6, .schema. And what this does is it just specifies the schema of the JSON objects. So they have a time that's a timestamp and action that's a string. Line 7, .option sets the max files per trigger to 1. So it reads the files one at a time for the stream. Line 8 sets .json to the folder with the JSON objects. So let me hit Shift Enter on that. So this is just setting up the source where we're going to read from. Now the next command cell, command 4, we're going to define the aggregate for that source data. So line 1, we're grabbing a library, pyspark.sql.functions. Line 3, I'm creating something called counts stream. This is my aggregated stream. I'm going to count the actions. Line 4, I start with my raw input stream. Line 5, I do a group by. Line 6, I group by the action field of the raw input stream. Line 7, I set up a time window. So raw input stream.time is going to be the timestamp that my window is based on. And I'm going to have a window of 4 hours. So every 4 hours, I'm going to count the number of actions, both open and close, and sum them up. 8 is the .count, which is the aggregate. So let's run Shift Enter on that. So that's complete. So now what we've done is we've set up the read part of our stream, where our source data comes from. Now in command cell 5, we're going to set up the write part, or the part that actually writes the stream to a memory table. So on line 1, I'm starting with count stream, which remember is my aggregate stream. And I call it .writeStream, .format memory, which just tells it to write to memory. .query name averages, this is a table that we're going to be able to query with SQL statements. It's going to be an in-memory table. .output mode complete, which just tells it to write all the data. .start. So I'm going to hit Shift Enter on that. And you see in the results it says stream initializing. So it's setting up the stream to write to it. So it's going to be a live stream. We just have to wait a minute or so for it to start up. Okay, so now in the results it says averages. And if I expand that, I'm going to see statistics about my stream. The number of records per second, that are coming in, the batch duration, the aggregation state. So you'll see these change as data comes in. There they go. So now I'm going to scroll down to command cell 6, and this is when I'm going to actually query the data that's coming in on the stream. So line 1, I go %SQL, which just sets it to SQL language. Line 2 is my SQL. I'm going to select the action and the window.end, which is the end of the 4-hour aggregation window. And I'm simply formatting it to look nice. It's going to be month, day, hour, minute. And I'm calling that time. And the third property is the count. That's the aggregated count. From averages, that's my averages table. Order by time and action. So let's hit Shift-Enter on that. And now I get a nice plot. Now, if you do this yourself and you haven't set this up, I've set up this plot. So normally what you'd see is this. You would see the table. And then at the bottom of results, you need to click the Display as Bar Chart button to see the chart. And your chart might not look the same by default. So to set it up, click Plot Options at the bottom of the results, and you get a customized plot window, and set it up the way I have set up here. Keys should be time. Series groupings should be action. So you're grouping by action. Values is the count. So we're getting the count per action for every end time. And it should be grouped as a type and display type bar chart. I hit apply, and this is what you get. So you can see how many open and closed there were every 4 hours. Now, if I run this again, it will update. And you see that since I've been talking, it's collected data at the stream, and we now have more data coming in. So in conclusion, structured streams can be constructed in a few lines of code with Spark, and the streams can then be queried at specific points in time. In Azure Stream Analytics, developers process streams using windowing functions. These functions work on time windows, defined by start and end times. Data is processed in batches, defined by these time windows. Stream Analytics offers windowing functions for several different time window strategies, and it's important to understand these strategies in detail. We're going to cover the following temporal window strategies: tumbling, hopping, sliding, session, and snapshot. Functions for these different window strategies are used in the group by clause of the SQL processing statement in a Stream Analytics job. A tumbling window strategy is when each window is a fixed size. This example shows a 10-second tumbling window. Each collection of 10 seconds of data is processed as a separate window. Note that tumbling windows don't overlap, and they're contiguous, meaning there's no time in between the windows. The end of one window is the start of the next. This is called tumbling window because sequential windows of equal size simply tumble one after another through the stream. This tumbling window example could be used to generate 10-second totals by performing a sum aggregate of the values in each window over time. With a hopping window strategy, the time window is always the same size, like the tumbling window, only the windows can overlap. There are 3 parameters to the hopping window: a time unit and a window size, which together define the size of the window. For instance, if time unit is seconds and window size is 10, then the window is 10 seconds. And then the hop size, which is how many time units the window moves forward on each step. In our example, there's a 5-second hop. Hopping windows are useful for things like rolling averages. In the example, the average of the values could be calculated every 5 seconds, and it could take the last 10 seconds of data into consideration for each average. An interesting detail is that a tumbling window is actually a special type of hopping window, where the hop size is equal to the window size. A sliding window considers all possible windows of the given length. In our example, we have a 10-second sliding window. To visualize this, imagine the window sliding smoothly from left to right. This means there are technically infinite possible window locations to consider with a sliding window. Of course, Stream Analytics doesn't calculate an infinite number of windows. Instead, it only considers windows in which the data has changed. So as the window slides, data points slide off the back of the window and slide into the front of the window. An example of using a sliding window would be if you were collecting thermostat readings and you wanted to know the average thermostat reading over the past 10 seconds at any arbitrary point in time. A session window strategy is used to group data points that occur within a certain time of each other. There are 3 parameters: timeout, maximum duration, and partitioning key, which is optional. A session window doesn't have a set size. Instead, when the first value is encountered, it starts a session window. As long as the next value occurs before the timeout time has elapsed, that new value is added to the current session window, extending the window and resetting the timeout. The window can only grow as long as the maximum duration before being ended. So the session window ends when either another value does not come in before the timeout expires, or the maximum duration has elapsed since the session window started. This effectively groups values that are close to one another time-wise. This could be used, for example, to determine when more than 20 thermostat values come in within 5 minutes of one another. The optional partitioning key will use an attribute in the value as a partition, and data with unique partition values will have their independent session windows calculated. This is good, for example, if our thermostat data was a mix of data from several thermostats, and the thermostat ID came in with each value. The thermostat ID could be the partitioning key, and therefore the session windows would be applied independently for the different thermostats. Finally, a snapshot window groups data that have the same timestamp. This simple type of time window might be used to help detect duplicate readings in our thermostat example. If we were reading data from a single thermostat, and the thermostat occasionally output duplicate readings with the same timestamp, then using this grouping would alert the logic that something was wrong if any group contained more than one value. In this video, I'm going to demonstrate how to collect and monitor time series data in Azure Time Series Insights. So I'm in Azure, and there are 2 resources that you need for this. You need an Event Hub, and you need a Time Series Insights environment. So the first thing we'll do is set up an Event Hub. So I'm going to click Create a Resource at the top left. On the Create a Resource page, in the search box, I'm going to type Event Hub. And in the pull down, I'm going to choose Event Hubs. On the Event Hubs page, I'll click Create. Now I'm on the Create Namespace page in the Basics tab. Under Project Details, I need to choose a subscription, and it's already done that for me. And then I need to choose a resource group or create a new one. So I'll choose my existing group. Under Instance Details, I need to give it a namespace name. So I'm just going to call this TSI Hub 2255. That's for Time Series Insights Hub. Location, I could just choose my location. Pricing tier, you can go with Basic. And then at the bottom left, you can click Review and Create. Now at the top in green, it says Validation Succeeded. So click Create at the bottom left. So now that that's complete, I'm going to click Go to Resource on the overview. And that takes me to my Event Hub's namespace overview. Now what we need to do now is create an Event Hub. So in the options on the left, I'm going to scroll down to the Entities section and click Event Hubs. Now there's an empty table of Event Hubs on the right. At the top of that is an Event Hub button with a plus, so click on that. And now I'm on the Create Event Hub screen. I need to give my Event Hub a name, so I'm just going to call it TSI Event Hub. I'm going to leave everything else default and click Create at the bottom. So now you see in the Event Hubs list on the right, I have TSI Event Hub. So now what I'm going to do is create my Time Series Insights. So I'm going to click Home at the top left. And then on my home page, I'm going to click Create a Resource on the left. Now I'm on the Create a Resource page. In the search box, I'll type Time Series Insights. And on the drop-down, I'll choose Time Series Insights. On the Time Series Insights page, I'll click Create. And now I'm on the Create TSI Environment page. I'm on the Basics tab. So I'm going to scroll down to Project Details. Now I've previously done this and I've noticed that it leaves everything filled in, but yours will be mostly blank. For subscription, you just choose your subscription. Resource group, you need to choose an existing resource group. Instance details, you need to give it a unique environment name. I gave it TSI 2255 previously, so I'll go with that. Location, just choose your location. Leave the tier at Gen 2. And then scroll down to Time Series ID. Under Time Series ID is a property name. This is very important. You should set it to tag ID with a capital I. The reason is because this is the property that's going to be used as a unique identifier by Time Series Insights. So the events that we're going to feed into it are going to have this as a unique identifier. Under Cold Store, you need to fill in a storage account name, and this is going to create a new storage account, so it has to be a unique name. I'm going to go with TSI Storage 2255. Storage account kind can be Storage v2. Storage account replication can be locally redundant storage. Everything else can be defaulted. At the bottom, click Next Event Source. That takes it to the Event Source tab. At the top, the first option is Create an Event Source. Choose Yes. For source type, you have IoT Hub and Event Hub. Choose Event Hub. For name, choose a unique name. Subscription, choose your subscription. Event Hub namespace, pull down the options and choose the Event Hub namespace that we created earlier. Then for Event Hub name, pull down the drop-down and choose the Event Hub that we just created. For Event Hub access policy name, it should fill it in as a default, which is root managed shared access key, so you can leave that as is. And Event Hub consumer group should also be the default, which is $default. So we'll use that. Now scroll back to the top, click Review and Create tab. And at the bottom left, click Review and Create. And that should initialize your deployment. I'm just going to pause until the deployment is complete. Okay, so my deployment is complete. So I'm going to click Home at the top left. And now in my recent resources, I'm going to click my new Time Series Insights environment. So now I'm in the overview of my Time Series Insights environment. So on the right at the top, I'm going to click Go to TSI Explorer. Now this takes me to an Explorer which currently is empty because we don't have any data. So what we're going to do now is flip to a Visual Studio project that I have, which is going to enter data into my Event Hub. So here's my code. I have a code window in the middle here, and I'm just going to step you through the important parts. So on line 19, I'm doing an eternal while loop, and on lines 21 and 22, I'm setting up two property values. The first one is tag ID. If you recall, that is the time series ID, the unique identifier for every event. I'm creating a random number between 0 and 2. So we're only going to have a few unique tag IDs. In real life, if we were, say, attached to an IoT hub, then this tag ID might represent a real physical device in the world. Like we might have 3 thermostats, for instance, and these are their unique IDs. Line 22 is just a value, and I'm just creating random values between 0 and 100. Line 23 and 24 are setting up the event, and on line 23 you'll see that it's a JSON event, and on line 26 we are sending it. Now in order for this to talk to our Event Hub, we need to set it up with the credentials. So that's on line 13 and 14. Line 13 we need the Event Hub name. So if I go back to Azure for a second, and I hit Home at the top left. And on my recent resources, I'm going to go to my Event Hubs namespace. And on the left, under Entities, I'm going to click Event Hubs. And on the right, I see my Event Hub name, which is TSI Event Hub. So if I go back to Visual Studio on line 13, I'm going to fill in TSI Event Hub. On line 14, I need the connection string, and that's the connection string to my Event Hub namespace. So if I go back to Azure and I click on my TSI Hub 2255 namespace at the top, and that takes me to the overview. Now on the left-hand side, if I scroll up and I go to under Settings, Shared Access Policies, on the right, you see something that you should recognize, which is Root Manage Shared Access Key. This is a default access key that we told it to use. If I click on that, a blade opens on the right-hand side, and partway down, it has a connection string primary key. I'm going to click the Copy to Clipboard button on the right of that. Then I'm going to go back to Visual Studio, and on line 14, I'm going to paste that connection string. So now we've entered the credentials to our Event Hub. So I'm going to hit F5 in Visual Studio, and we're just going to let this run. So it's running in the background right now. So I'm going to go back to Azure, and I'm actually going to go back to my TSI Explorer, and you'll see something interesting. At the top, we have a chart appearing. What this chart shows you is what's in warm data, which means what's loading in from the Event Hub right now. If we take a look at it, we can actually drag a time window, and we don't actually see anything yet, but we will see data coming in as we expand this window. And we can hit refresh at the top. And so now when I hit refresh, I see that it has some bumps in it. The bumps are actually our events coming in from our Visual Studio program. So what we need to do now is we need to chart this. So we'll start off by charting it. Another important piece of information you'll see is at the bottom, you see there's two values, 0 and 1. Because Time Series Insights knows that our unique identifier is tag ID, it's actually creating a new entity for every ID. On the left-hand menu, there's two buttons, and we're currently on the top button. If you click the second button, that's Model, on the right-hand side, you'll get a list of instances. And you see the time series ID is 0 and 1. So these were automatically created as the data came in. They're using a type called Default Type. And in the top menu, if I choose Types, and if I take a look at Default Type by going all the way to the right in the Default Type row and clicking the Edit Type button, so I get an Edit Default Type window pop up. There's Properties. Properties is just a name. If I click Variables tab, I see it has one variable. It's an event count, and it's an aggregate. This is a default type that's created for you that basically just adds up the events. So I'm going to click Cancel on that. On the left-hand menu, I'm going to go back to the first button for Analysis. And if I hit Refresh at the very top, we'll see that we have even more events now because we're sending several events a second. If I go down to where 0 and 1 are listed under Hierarchies, if I click on 0, I get an option of what I can look at, and I can look at that event count property. So I'll click on that, and I get a chart on the right-hand side. And you can see the events coming in for ID 0. Now, I can also look at ID 1. So if I go back to the left, I click on ID 1, and I choose event count. Now I have two charts on the right-hand side. One is blue, one is purple in this case. The top one is the event counts for ID 0, and the bottom one is event counts for ID 1. And if I go to the very top, where it shows the warm store query, which is this chart at the very top, I can actually scroll my time window, and you see at the bottom, it updates and shows me that time range. And there's way more events happening there. So I'll just scroll that down a bit. Now what I would like to see is I would like to see the values that are coming in. Now I want to show you that we're actually getting the data. So just above the charts on the main menu, on the right-hand side, there's a button that says More Actions. I click that, and under that, I can click Explore Raw Events. This shows me the raw events. There's 442 events, it says at the very top. And you can see there's a tag ID column and a value column. So I want to chart the values. Right now it's charting the counts of the tag IDs. So I'm going to click Close. Now, on the far left, I'm going to choose the Model button again, the second button. And what I need to do is redefine the type. So on the right-hand side, the tabs at the top, I'm going to click Types. Now, in the table below, I see my default type. I'm going to go all the way to the right of that, and under Actions, I'm going to click Edit Type. And then on the Edit window that pops up, I'm going to click the Variables tab. And below the table that shows me my variables, which is right now just event count, I'm going to choose Add Variable. Now I'm on the Add a New Variable window. I can give it a name, and I'm going to call this Value. And under that, the kind is going to be numeric. And if I scroll down a little bit, under Value, I'm going to leave it at Custom. And it sort of shows you what you should type. $ event, and then in square brackets and single quotes, the name of the column, and then .double with a capital D if you want to cast it to a double. That is exactly what we want to do. I will type that in. And remember, our column name is value in the JSON. .double. So I'll hit Apply. And then at the bottom right, I'll hit Save. It's publishing that now. And it says Type Created, Edited Successfully. So on the left menu, I'm going to click the top button, which is the Analyze button. And now we're back to the graph. Below the graph, it shows the different series that I've added. I'm going to hit the little trash can to the left of those to delete them off of the chart, so we get an empty chart. Then on the left-hand side, I'm going to choose one of my IDs. I'll choose 0. I'll click that. And now I have two options, event count and value. I'm going to click Value and click Add. Now on the right-hand side, we get a chart. And remember, I'm using random numbers. That's why this chart looks so crazy. So it's using random values, but I can see my values showing up. If I go back to the left and I click on the 1 and I choose Value and I choose Add, I can see both of them. So in conclusion, time series insights can collect time series data from an IoT hub or an event hub, and once it's collected the data, you can then analyze it graphically. In this video, I'm going to demonstrate how to set up an Azure Stream Analytics job and then process a stream. So I'm in Azure on my home page, and I have two resources set up under Recent Resources. One of them is a Stream Analytics job, and one of them is a storage account. Now let me just show you quickly how you would set up your own. So on the top left of my screen, I'm going to click Create a Resource. On the Create a Resource page, in the search box, I'm going to type storage account. We'll create the storage account first. And in the drop-down, I'll choose storage account. On the storage account page, I'm going to click Create. Now I'm on the Create Storage Account page under Basics. And under Project Details, I need a subscription chosen, and it's already chosen mine. And I need to either create a new resource group or choose one that's already existing. So I'll choose the one I already have. Under Instance Details, I need to give it a storage account name, and it has to be unique. So I'm just going to call this Storage 2256, just as a random name. Location, I'm going to choose Canada Central, but you can choose whatever location you'd like. And I'll leave the rest defaulted, and at the bottom left, I'll click Review and Create. So now it says Validation Passed at the top in green. So for your own, you can click Create at the bottom left. To do the next one, I'm going to click Home at the top left. And on my home page, I'm going to click the Create a Resource button again at the top left. And on the Create a Resource screen, I'm going to type Stream Analytics in the search box. And from the drop-down, I'll choose Stream Analytics Job. On the Stream Analytics Job page, I'm going to click Create. And now I'm on the new Stream Analytics job page, and it's asking me for a job name, so this has to be a unique name. So I'll call it Stream Analytics 2256. Subscription is pay as you go, that's fine, you just choose a subscription. Resource group, either create a new one or choose an existing one, so I'll choose my existing one. Choose a location. Hosting environment should be cloud. Streaming units you can turn down to 1, and then just click create at the bottom left. So that's how you create your storage account and your Stream Analytics job. Now I'm going to click home at the top left, and I'm going to show you how you set up your Stream Analytics job. So under recent resources, I'm going to click my Stream Analytics job. So now I'm going to go down in the menu on the left to a section called Job Topology. And in Job Topology, there are 3 required aspects of this Stream Analytics job we need to set up. The first one is inputs, the second one is outputs, and the third one is the query itself. So I'm going to click on inputs, and on the right I have an empty table of inputs, and at the top left I'll click Add Stream Input. I have 3 options: Event Hub, IoT Hub, or Blob Storage /ADLS. I'm going to click Blob Storage, and on the right hand side I get a blade that's asking me for an input alias, so I'm going to keep it real simple and just call it input. Subscription is already filled in. Storage account, I choose my storage account. And authentication mode, I'm going to choose connection string to keep it simple. It fills in the storage account key or the connection string for me. If I scroll all the way to the bottom, event serialization format, I'm going to choose CSV comma separated because that is what I'm going to put into my input stream. So what we're going to do is we're going to use CSV files as a form of streaming input. So as we put CSV files into our blob storage, this is going to pick them up and process them as if they're streaming input. And I just realized that I forgot to specify a container. So currently under container, if I scroll back up to the top, I want to choose create new, and I'm going to enter the container name. And to keep it simple, I'll just call the container the same as the alias, which is input. So it's going to create that container in my storage account for me. Now I can click save at the bottom of the blade. So that's created my input, and I can see it on the table on the right. So the next thing we're going to do is set up our output. So on the menu on the left, under Job Topology, I'm going to click Outputs. And on the right-hand side, I get an empty table. I'm going to click Add at the top. And now I have a lot more options. I'm going to choose Blob Storage again as my output. And I get a blade on the right called Blob Storage /ADLS Gen 2. It's asking me for an output alias, so I'm just going to call it output. Subscription is already filled in. Storage account, I will choose my storage account, which in this case is going to be the same storage account. For container, I'm going to click create new, and I'm going to call my container output. Authentication mode, I'm going to choose connection string. And if I scroll farther down, event serialization format, again, I'm going to choose CSV comma, because I want my output files to be comma separated CSV. I'm going to scroll down to the bottom, and there's a section that says maximum time. I'm going to fill in 1 minute, because what this means is that regardless of how many records are coming in on the stream, this will batch process at least every 1 minute. And then at the bottom, I'm going to click Save. Okay, so that's created my output. I can see it in the list. So now going back to the left menu, under Job Topology, I'm going to click Query. And on the right-hand side, I get a query window. Now, I'm going to place a query in here. This is a query that actually processes the input and creates the output stream. So in the query window, on line 1, I says select. Line 2 is star, so I'm selecting everything. Line 3 into, line 4 output. So output is the name of my output alias, if you recall. And line 5 is from, line 6 is input, that's my input alias. Line 7 is a special clause, having, and I cast the age field as big int. Age is going to be a field in my CSV. And I'm casting it to a big int, and I'm comparing it to make sure it's greater than 40. So what this is going to do is it's going to copy all of the events from the input to the output as long as their age is greater than 40. So let me hit Save Query just above the query window. So now what I'm going to do is go back to the left menu. I'm going to scroll to the top, and I'm going to click Overview. Now on the right-hand side at the very top of the overview, there's a Start button. So I'm going to click Start. On the right-hand side, I get a blade that says Start Job. And Job Output Start Time, I'm going to choose Now and click Start at the bottom. Okay, so that's complete. And you can see at the top of my overview, the start is grayed out. And it says starting. If I refresh by clicking Activity Log on the left and then clicking Overview, you'll see in my overview on the right, it says running at the top. So now what this is doing is it's actively running and waiting for streaming data to come in the input. So let's give it some streaming data. I'm going to click Home at the top left. And under Recent Resources, I'm going to choose my storage account. Then on the overview on the right of my storage account, I'm going to click Containers. In the container list on the right, you can see the two containers that it created, input and output. And there's also a logs container, which it creates as well. So I'm going to click the input container. And on the right, at the top, I'm going to click Upload. And I have a file set up. So on the right, I get a blade that says Upload Blob. And under Files, I'm going to click the Browse button to the right. And I'm going to go to my file, which is people.csv, and click Open. And then on the blade to the right, I'll click Upload. So now I'm just going to close the blade. And in my list of input blobs, I see people.csv. So now that's been written, it should be picked up in the stream. At the top, I'm going to click my storage account name. So it takes me back to the container list. I'm going to click on Output. And you can see already that there is a file in my output now. It's got a big long name. If I click on it, this blob, then on the right-hand side, I get a blade that's got blob details. I will click on the tab that's called Edit, which is fourth from the left. And at the bottom, I'll click Preview. And I can scroll this table that shows up, and I can see that it's picked up Lenny Kravitz 48, Steven Seagal 55, Lisa Jones 44. Notice that all of their ages are greater than 40. And it's also got an event process UTC time. So it tells me when the event was processed. Now, if I click my storage account name at the top left of the screen, so I go back to the containers list, and I click Input, I just want to show you what the input was. So here, in the input list, I'll click people.csv. On the blade to the right, I'll go to the Edit tab. And you can see what the input was. There was actually two people whose ages were less than 40. Line 4, Barb Smith is 24. Line 5, Leonard Packer is 39. So they were filtered out. So in conclusion, Azure Stream Analytics processes streaming data by accepting data at an input, running a SQL statement, and then outputting the result. So in this course, we've examined how to use, implement security for, and understand the inputs and outputs of Azure Stream Analytics. We've also examined how to create user-defined functions and optimize jobs. We did this by exploring processing stream data with Azure Stream Analytics, Azure Stream Analytics inputs, outputs, and user-defined functions, processing data using Spark Structured Streaming, using Stream Analytics windowing functions, setting up time series data, and creating a Stream Analytics job. In our next course, we'll move on to discuss Azure Synapse Analytics.